And then to determine whether it's right triangle, remember the longest leg is always going to be the hypotenuse, and we're just going to do a squared plus b squared equals c squared and see if it's true. So I'm just going to circle the longest leg on each one so I know. Oh, look at that, it's in order. So it's either a right triangle, not a right triangle, or not enough information. Well, all of these have 3 legs, so we have plenty of information. And this should be 8 squared plus 14 squared equals 16 squared. That's going to be 64. 64 plus 15 squared. 196 equals 256. Well, 64 plus 199 is 263. That is not equal to 256, therefore this is not a right triangle. Okay, and right here, 10 squared plus 12 squared equals 16 squared. Alright, so this is going to be 100 plus 144 equals 256. Well, that's 244, so nope, not a right triangle. 30 squared plus 40 squared equals 50 squared. Well, let's see, that's going to be, I don't know, what, 900? Just 3 squared, add 2 zeros, plus 1600 equals 2500. Yeah, add those together, and I do get 2500. So that is a right triangle. And then our last one, 15 squared plus 36 squared equals 39 squared. Well, let's see, 15 squared. It's going to be 225 plus 36 squared, 1296 equals, let's see, 39 squared, 1521. Let's see, what's 225 plus 1296? That is 1521. Those equal each other, check. So that's going to end up being a right triangle. Look at that. Didn't know that, now I do. Not hard, just a little bit of tedious work there. You can do it. Okay, now we're going to start talking about some theorems we've talked about, which you're going to definitely want to get your paper. That paper I gave you today, or you should be getting, as you put your theorems down on it, you can use that in addition to your notes for the test. That can help you. That's a big boost for the test, right? So I recommend it. It says, consider the triangle XYZ in the figure below. The perpendicular bisectors of the sides are TS, US, and VS. They meet at a single point S. In other words, S is the circumcenter, right? That means if it's the circumcenter, I know that SZ, SY, and SX are all the same length. And if they're perpendicular bisectors, I know that, right? 4, 1, 2, 3, 4. Some good stuff right there. Okay, suppose VS equals 66. All right, if VS is 66. And 66 YZ equals 82 YZ, that's this whole thing. 82 and CS is 110, or ZS 110. Okay, let's see what's going on here. 110. Find XS UZ and VY. Okay, I can do this. Okay, first of all, if I know that ZS is 110, guess what? XS is the same measurement. So XS is 110. That was easy. Let's look at UZ. Well, if I know this entire length is 82, and if this is a perpendicular bisector, the definition of a bisector is it cuts these two lines in half, correct? Which means these sides equal each other, so I've marked them up like this. 3 lines equals 3 lines, right? They're congruent lines, which means let's take 82 and divide it by 2, which is 41. So UZ is 41. Because this side would be 41, and so would this side be 41. And if I could label that 110 after we did it. Okay. Now we want to find VY. VY. Okay. Well, to do that, I'm going to use this right triangle right here. Maybe I should highlight it to help us out as we're looking at it. Again, I'm missing one of the legs, and let's call that X. And here's what I do know, though. That leg is going to be equal to the square root of the hypotenuse, which is 110. 110 squared minus 66 squared. Okay, which is going to equal the square root of, I don't know, I'm going to use a calculator. 110 squared, which is 12,100, minus 66 squared, 4,356. Let's see. That equals the square root of 7,744. And second function, square root of 7,744. Ooh, that's nice. That's 88. Look at that. So I know that this measure is equal to 88. Here's what I also know. XV and VY are the same measure because, again, that was a perpendicular bisector. SV is. So that means VY equals 88 as well. Boom. Good problem. Love it. Take a look at that for a minute. Let's do this. Okay. Down to our last 2 problems. All right. We're on to number 7. The medians of triangle JKL are JN, KP, and LM. They meet at a single point Q. In other words, Q is the centroid of triangle JKL. Okay, so if the centroid, we know a few things from that, right? But we'll get to that. Suppose QP is 11. So let's do that. QP, this is 11. QM is 10. And JN is 39. So JN, that's that whole thing is 39. Find the following lengths. We want to find LM. Okay. Do you remember we had that theorem that says, hey, if it's the centroid, then we know that LQ equals 2/3 of LM, right? Well, here's the thing. If that's 2/3 of LM, then that means QM is 1/3 of LM, correct? Because that's all that's left of LM, right? We have LM, we have 1/3 right here and 2/3 right here. So wouldn't it be that LQ is just 2 times that, right? Because if this is one of the 3 parts, then we need 2 more of those 3 parts, and each are going to be worth 10. So that means we're going to have 2 times 10 equals 20. So we know that this is 20. Awesome. So if I know that LQ is 20, what's 20 plus 10? It's going to be 30. Or I could have just come down here. I could have used this, right? I could have also said, just for those of you looking for different ways to look at this, if that is 1/3 of LM, then I could say I know QM is 10, so 10 equals 1/3 LM. Multiply both sides by 3, and I get 30. That cancels out, equals LM. Same answers. Everybody see that? Okay? All right, so that's a great start. Let's look at JQ. JQ, well, if I know JN is 39, I know that JQ equals 1/3 of JN, which means JQ equals 1/3 of 39. Not 1/3, I'm sorry, 2/3. That's the long part. That's the long part. Please forgive me, that should have been 2/3. And what's 2/3 of 39? Well, 3 goes in there once. 3 goes into 39 13 times. 2 times 13 is 26. So I know that JQ is 26. And last one we want to look at is KQ. Well, similar to kind of what we did up here, if QP is 11, and I know that, let me just rolls up a bit. QP, right, this distance right here is equal to 1/3 of the total distance KP. QP equals 1/3 of KP, right? So, if I know that's 1/3, then this is 2/3, right? Because I know that KQ is 2/3 of KP. So if this is 1/3 and that's 2/3, then that's going to have 2 of these 11s. What's 2 times 11? 2 times 11 equals 22. So that's just 22, right? Together they make 33, but we just want that little section right there, so that's 22. I could also have used this just again to show you different ways you could do it. I could say, all right, if that's true, then I know that QP is 11, which equals 1/3 of KP. Multiply both sides by 3, right? To undo that third. Oh, sorry, you can't really see it. To undo that third, we're multiplying both sides by 3, and I get that 33 equals KP. And if KP equals 33, the whole thing is 33, right? All the way down is 33. Then 33 minus 11 is 22. So different ways you can come about this, but yeah, lots of great stuff. Should you have that down? If you have any questions, let me know. All right, let's go on to the next one. Last one. Boom. It's a good problem. The angle bisectors. Oof. Angle bisectors. Good stuff. Oh, now we're doing angle bisectors. Ooh, I like this one. Angle bisectors of triangle PQR are PZ, right? PZ, QZ, and RZ. Great. They meet at a single point Z. In other words, this is the end center. If it's the end center, then what do I know? I know that ZX, ZW, and ZY are the same length. And each of these distances meet over here at 90 degrees. Great. If WZ is 16, PZ is 21, so PZ, this is 21 right here, that hypotenuse. And the measure of angle P, or WPY, let's see, WPY, so this whole thing right here is 92 degrees. I'm not going to write it like that. I'm actually going to write a little line 92 degrees. This is the whole thing. And this is an angle bisector, so we'll get to that. And then we know YRZ is 18 degrees. So YRZ, so this little inside is 18 degrees. Okay, okay. Note the following. Oh, it's not drawn to scale. That's fine. Whatever. So let's take what we know. We want to find the measure of angle YRX. Well, if that's an angle bisector, by definition, it cut this angle in half, so we just do 2 times 18 equals 36. We now know that this whole thing is 36 degrees, right? So YRX is 36 degrees. Now we want to find XQZ. Okay. Well, if I know this whole thing is 92, this whole thing is 36, let's add those together. 92 plus 36 equals 128. Subtract that from 180. 275. So I know that this entire angle is 52 degrees. Again, the ZQ is an angle bisector, right? So that means it's going to cut this in half. So if I want the measure of angle XQZ, which is half of that, it's going to be 26 degrees. And again, that's just 52 over 2 equals 26. Okay, now I want the measurement of XZ. XZ, well, if I'm told that WZ equals 16, then what does XZ equal? 16. Boom, look at that. Because WZ is congruent to XZ, so they're both 16. Perfect. All right, that's the last of the questions. Get ready. This is your best study guide for the test because this is what the test is written off of. So with that said, peace out.